A very warm welcome to everyone. I am Rohan Joshi and my team consists of Spandan Kevte, Kaustubh Khisti and Yash Kulkarni. We are here today to outline our strategic vision for elevating the electric scooters in a rapidly evolving market. This presentation will detail our data-driven approach to enhance the product and solidify our position as a leading provider of innovative and customer-centric mobility solutions. We will explore the key features driving customer preference, how can we optimize a product to capture a larger segment of the market, and discuss our commitment to innovation to achieve our business objectives. This strategy is the result of careful analysis and is designed to drive growth and profitability. The key factors and understanding of this study shall be addressed by answering the question which is focusing upon the different aspects of it. To understand this, I'll start with listing top 10 features which should be present in an application for an electric scooter, including the top 5 features which are most critical for its betterment. These features can be understood or can be split into 4 important categories. Core functionalities. These core functionalities include the features which are extremely necessary for rapid development of the application and the brand. It consists of AI-powered predictive maintenance, a game changer consisting of neural networks forecasting failures, battery health, component alerts, and self-calibration. It also consists of crowdsourced traffic intelligence, which shares road conditions, parking, theft alerts via a mesh network of different types of automobiles connected together. The second part consists of the user experience enhancements. This consists of augmented reality navigation or the AR navigation for camera overlaying routes, highlighting safe paths, and adapting to different terrains. It also consists of a context aware voice interface. This consists of natural navigation, emergency help, and multilingual support. Adaptive ride personalization, which adjusts to posture, heart rate, facial recognition statistics. A haptic feedback guidance, which consists of vibration guiding turns, alert to speeds, battery levels. It also consists of a neuro-inclusive accessibility, which includes dyslexia fonts, safe routes, and sign language. A 3D printing customization marketplace. Then, moving to the next part into innovation and security block, we can understand blockchain enhanced security in terms of NFT ownership, anti-theft secure logs, crypto rewards, and other important secure features using the power of blockchain. It also consists of metaverse integration for virtual challenges, AI components, and NFT showrooms. This were the overview of the 10 features that are extremely necessary for the rapid development of an application. Moving into details with the 5 features that are critical can be considered as 1. The AR navigation and terrain adaptation. It directly addresses 42% of the customer complaints in the market about discomfort on gravel or non-tarred roads. By overlaying optimal routes and adjusting the scooter power distribution in real time, riders can experience smoother journeys. AR integration reduces cognitive load compared to the traditional map interfaces, potentially increasing the app engagement by a solid 30%. The second factor is the AI predictive maintenance system. This solves charging degradation and sudden power loss issues. Machine learning models analyze 15 plus battery health parameters and can predict failure 2 weeks in advance, reducing the warranty cost by 25%. This aligns with the company's zero key operational goal while building user trust through transparency. The third important factor should be a biometric adaptive ride personalization. This tackles the weight to the power ratio by the complaint indirectly. By auto-adjusting torque and suspension based on rider weight posture, the scooter compensates for its structural mass. Integration with health data also creates wellness focused differentiation, a key tune in micromobility. The fourth feature that should be there should be a haptic feedback guidance system. It addresses 68% of notification related complaints in the market through tactile alerts that work with cellular connectivity. Direct vibrations prevent app over interface, and battery level haptic patterns eliminate these surprise power offs that happen in the case of electric vehicles. The fifth point is a crowdsourced mesh network, which is one of the revolutionary ideas in this field. This solves both navigation and theft issues. Scooters sharing real-time road conditions via BLE 5.2 create a self-healing data network, reducing cloud dependency by a solid 60%. This peer-to-peer system also enables stolen vehicle tracking when GPS is disabled, a solid 200 million annual industry problem. Moving on to the next question is the potential reason for identifying two of the issues that a customer might face and the test scenarios that can be used to test and ensure that these particular issues have been fixed. One of the common solutions can be always derived from a very integrating problem. One of the problems in the market is a vehicle weight being too high. This problem is issued and faced by a multiple users where the weight of the vehicle is too high for a particular user to handle, leading to multiple road accidents. The scooter uses heavy motors or batteries compared to the competitors. They can be using a lighter, higher density compartments. The frame and the chassis can be overbuilt with heavy materials like steel instead of lightweight alloys. Some parts may also be outdated and add unnecessary weight. These are the conditions that can cause the heavy weighting. The test scenarios can consist of comparing the weights of the key components to identify the areas for reduction in comparison with their competitors, and performing load tests on the frame to ensure safety while using lighter materials. We can also measure the energy efficiency to confirm that weight reduction improves range and performance. This is another important factor that it tackles since range is also an important concern and performance is also hampered when a vehicle gets too heavy on certain sites. The next case or the next problem is poor ride comfort on rough roads. Focusing on the Indian terrain, which consists of unproper planned roads, can be very difficult for a rider to transfer his weight and to move in a particular direction. The potential reasons for this is suspension setup being too stiff or linear, failing to absorb the bumps effectively. Tires have rigid sidewalls that transmit shock instead of cushioning them. Handlebar and footpeg position also cause rider fatigue on uneven surfaces. The test scenarios for these particular factors consist of using accelerometers to measure vibrations on rough roads and competing with their particular competitors. The test suspension durability with repeated impact cycles to ensure reliability and after improvements. We can also conduct comfort studies to optimize ergonomics and reduce fatigue in the particular riders. By addressing these two important questions, we are focusing on an approach that is different and that is focusing upon the actual further enhancements in the application, along with addressing the questions or the problems which are faced by a major proposition in the current industry.
Thank you, Rohan, for setting the stage. Let's move to our strategy for launching the new electric scooter app designed to address user complaints and drive market success. This table outlines 5 key actions split between inside out, which builds on the internal strengths, and outside in, which responds to the customer and market needs. Starting with the inside out actions, marked by the gear icons. First, we'll adopt agile environment development using the 2 week sprints to create an intuitive interface. This directly tackles the complaint about the clumsy app, making it a much more seamless, useful experience. Our engineering team's expertise will make it a feasible option. Second, robust testing will deploy automated scripts to verify notification delivery and app performance. By catching issues early, we align with the goal for zero key issues at launch. Shifting to the outside in actions marked by the user icons, the third competitive benchmarking will analyze rival apps like those of Aether to ensure features like Google Maps integration meet market standards. This positions us to climb to a second place. Fourth, a targeted marketing campaign on platforms like Twitter's, Instagram, billboards, and ad campaigning will show our improved feature and experience delivered, driving the sales upwards, just like we aimed for. Finally, the customer support integration embedded in our app feedback tool allows for real time issue reporting to boost user retention and address past dissatisfactions. These actions blend into the internal capabilities with external demands, ensuring that the app is reliable, competitive, and user focused. Competitor data is available is assumed as noted here. Now, let's ensure the app's data performance supports these features. Next, we'll address the app's data performance issues, which cause delays in notification and outdated information. Key customer pain points. This flowchart would rather explain the data journey from scooter to the application, with red boxes highlighting the issues and green boxes showing our fixes. 4 issues disturb performance. Network latency slows the data transfer in low signal areas. High data volume from battery to GPS metrics strain our clouds. Inefficient processing delays the updates, and poor sync logic leaves the app showing stale data. These explain why users miss timely alerts. A 5 improvement resolve these. First, edge computing processes critical data like battery levels on the scooter itself, cutting cloud reliance and speeding notifications. Second, an optimized pipeline uses MQTT protocols for real time streaming, assuming our hardware supports it. Third, The local caching stores recent data on users' phone, ensuring access even offline. Fourth, a scalable cloud infrastructure leveraging AWS CDN handles large data volumes efficiently. We assume the standard cloud access. Finally, retrying the mechanisms manage sync failures, ensuring reliability in weak signals. These challenges deliver a fast, accurate data, directly fixing notifications, delays, and outdated displays. They support the app features like real time battery updates and align with our goal for a flawless user experience. Thank you for your attention and hand over to Kaustubh to discuss the AI recommendations.
Building a smart scooter app that is will be focusing on battery metrics, particularly focusing on charging discharging rates and battery cycles. The next is ride data, distance traveled, speed, route taken, terrain type, and ride duration. All of these things combined will provide us greater analytics into the rider's data. The next is environmental data. As we all know, environmental data plays a big role in riders in a vehicle's life. So if it's a summer, you will have greater optimized usage of battery while as compared to a winter season. Moving on, all of these things will be considered to so as to collect data and optimize our battery usages. The next is user behavior. We'll be focusing on user behavior, that is the frequency of rides that he takes, the preferred routes that he uses, and lastly the app interaction pattern so as to improve our user interfaces. Next is maintenance data. The motor performances, tire pressure, brake usages, and any errors that the system throws out from the vehicle. All of these things will be maintained and collected in and stored in cloud storage such that they can be used for greater analytics. The next is ML and AI uses. Firstly, we'll be using ML to analyze battery health and ride data to predict when components might fail. Secondly, route optimization using AI. If there's a congestion on a particular route X, then we'll suggest that the rider takes a particular route Y in order to uh, save some time. Next is personalized notification. Based upon the user's usage, we can suggest that before going to a destination X, he can recharge the battery so as to reach the destination in that particular battery itself and have surplus battery as well in order to come back. The next is battery life prediction. Estimate remaining battery life under the current conditions, speed, and terrain. All of these things will be analyzed using machine learning and AI. Lastly, we'll be giving recommendations for the driver in this app, that is battery management, route optimization, maintenance alerts when there's maintenance due of the vehicle, driving tips, how the rider can optimize his driving. Lastly, charging guidance when the rider should charge his battery. Lastly, we'll be focusing on financial success, on how the company can grow financially. The first is revenue growth. The total revenue to track the sales should increase in the upcoming 6 months. The next target will be profit margin per vehicle. We have to increase it to 10%. As of now, it's going at 10% loss. So we'll have to reduce it, we'll have to increase it and gain a 10% profit per vehicle. The third point is market share. As of now, we are the fourth best competitor. We have to go to second best competitor in the market and be the second best competitor. Customer acquisition rate, target new customers, customer retention rate, measure repeat purchases to assess satisfaction. With all of these things, we'll be having a good financial base. Now we'll move on to operational metrics such that all of these things go hand in hand and the company performs better. The first is defect rate. Reduce the key issues to 0 in first 3 months. As of now, they are in we are having 6 months, so we have to reduce it down to 3 months and later on reduce it down further. Charging time, we have to ensure that the charging is done in less than 4 hours. Production efficiency, we have to assemble scooter in 4 hours compared to 5 hours, which is the current assembly time required. Lastly, Customer satisfaction, improve our user feedback score by 20%. That is the most essential part. We have to ensure that our customer is satisfied. Lastly, the delivery time should be shortened to just 7 days, such that the rider gets the best user experience. That is it, and over to Yash. Thank you.
Moving on, we have the evolution of electric vehicles till the present date of 2025 and in the coming 10 years. The electric mobility were basically more like a compromise than a choice. In the early 2010 to 2015 areas, the EVs were basic, functional, and largely unseen in the mainstream. Scooters are built for short distances and for city use. Charging took up to 8 to 12 hours with basic range of 80 to 100 kilometers. The dashboards were limited to speed and battery bars, which had no connectivity, no smart diagnostics, and no intelligence. Moving on to the decade of 2015 to 2025, we are now living in a world where EVs are smart devices on wheels, which have integrated with apps, GPS, Bluetooth, as well as cloud services. They have features like real-time diagnostics, ride analytics, remote lock and unlock (OTA) features, as well as ride personalizations. The charging has improved also drastically, with moving from 8 to 12 hours to 4 to 6 hours. And in the upcoming 10 years, what we are about to see is solid state graphene batteries with 600-kilometer plus range and ultra charging of 10 minutes itself. Emotionally aware interfaces, dashboard that adjust based on your mood, the weather, or even your schedule, dimming screens, switching to relaxing music, or reminding if you have forgotten an errand. We also have self-monitoring and predictive maintenance, where scooters can sense the wear and tear and schedule services before anything breaks. We also have two more features such as auto balancing and self parking, along with full ecosystem sync, where the scooter syncs with your smartwatch, smart home, etc. Moving on to the next slide, now we have UI. The UI is divided into majorly two parts. Looking at the future evolution of the electric scooters, we have need to have UI and good to have UI. The need to have UI contains real-time ride stats such as speed, battery percentage, range, motor temperature, etc. We have smart navigation systems integrated with Google Maps. We also have ride safety alerts such as collision, proximity alerts, as well as speed limit alerts. And then lastly, app synchronization with routes, trip history, and service logs. Now, good to have UI contains the following features: emotion-aware display, auto brightness based on ambient lighting and your mood, voice commands such as take me home or call mom, etc. We also have media and call control such as play or pause music, accept or reject calls, and more. We have gesture or touch swipe navigation and smart assistant integration such as remind me to charge at 8 p.m. or is my tire pressure low, and more. And using these specific need to have and good to have UI features, we have tried to design a minimalistic and smart UI system which would have battery and range display, speed, navigation snippets, and weather alerts, as well as it would also have scooter modes such as eco, sport, customs, and more. Moving on to the navigation part, if you swipe left on this UI, you can see ride history and stats like average speed, distance, and efficiency. If you swipe right, you'll see notifications and warnings such as battery, tire pressure, etc. Tapping the navigation card will showcase expanding the Google Maps, and so tapping on the docs icon will retrieve all the important documents such as RC, license, insurance, etc. One more new novelty-based addition feature in this is AI-based ride mood detection, which helps the UI to adjust the lighting as well as the dashboard based on the mood of the rider. So, for example, if your mood is happy or jolly, it will help you listen to happy music. It will showcase bright colors on the UI. Whereas if your mood is sad or melancholic, it will showcase sad music as well as dim colors on the UI. Now that we have seen all the good to have and need to have features in the UI and the UI systems also, we'll move on to concluding this entire case study. But conclusion would include this. By addressing the customer complaints while innovating the cutting edge features, the company can effectively stand out in a competitive market. By ensuring the balance between cost management and value addition, we can ensure an efficient, enjoyable, and safe ride experience, which will empower the company to accelerate to great heights and making it a market leader in the upcoming year. Thank you.